Okay, so one thing I told you guys I would check on, and I meant to email you and I didn't email you, but I did check on this. I do not have the room downstairs for the Friday exam, which means the final exam. I think I had told you that I thought I might have the 1108, Snell Hall 1108 room for the Friday exam. I don't have it for the Friday exam. I have it for your all's exam on Wednesday, but I don't have it for the Friday exam. But if you want to take it on Friday, I have a limited number of seats. If you want to take it on Friday, that's a possibility. It will be at whatever time is on the syllabus. I can't tell you right now. Yes, I can. 8 o'clock in the morning. So if you want to take it Friday at 8 o'clock in the morning in Central Wing, then that's a possibility, but you have to tell me and make sure I have room. You cannot just show up. You have to tell me. So if that's something that you're possibly thinking of doing, then let me know and we'll try to work that out for you. The second thing I needed to tell you is that on tomorrow, Tuesday, there is no pass. There was pass today, but there will not be pass tomorrow. Okay? And I think that's all. Everything else, well, I sent you an email. Let's confirm that email though. The email told you that your homework is due when? Thursday, November 30th at 8 p.m. Okay. That email said something else. What else did that email say?
It would be closed.
Oh, that was just for them. Yes, that was a question that 8 o'clock class asked me. They said, is sapling going to be down during Thanksgiving? And I didn't think they would be. And they had seen that announcement, so I just wanted to confirm. That's not that it's going to be where you can't access it. That's just so the customer support is down. You can access sapling on Thanksgiving Day while you're eating your turkey, okay? You can do that, all right? So that was the other thing. All right, is there anything else I need to tell you all? That's that kind of thing. I don't think so. I do know this. What you need to make sure you have printed out for Monday are the day 26 notes. Make sure for Monday you have the day. That's the last notes, okay? That's all that's left on there right now. I'm going to probably create another few pages of notes that will be kind of like a review over some naming. I think we need to do some more naming and drawing. Either I will bring them or I will tell you to print them out for next Wednesday. But Monday, you will not need those for Monday because we won't be ready for them Monday. But next Wednesday, we will need those. All right, so let's get started. While I'm pulling all this up, let's run through those functional groups. What's an alcohol? What is a carboxylic acid? C double bond O, OH. What's an aldehyde? Okay. What is a benzene ring? What shape? Hexagon. What's the rotating bonds? Single, double rotation. Good. Okay. And it is the 6-6, 6 carbon, 6 hydrogen. What is an alkene? C double bond C. What is an alkyne? C triple bond C. What is an ether? COC. What is ester? What's the abbreviation for a carboxylic acid rather than C double bond O, OH? What's another way to write it? Carboxylic acid. COOH or CO2H, okay? What's a shorthand way of writing ether? Which you basically have already said it. It's just COC. What is the shorthand way of writing an ester? COOC or CO2C or even just CO2. All right? What's an amide? C double bond O to an N. What have I missed? I thought I did. CN is an amine. C-N, alkyl halide. C bonded to a halogen, single bond. Did I do ketone? What is a ketone? C double bond O between two C's. Good. All right. Guys, I hope that you're studying these every day. Please, 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 please study these every day so that you know these. Actually, let me see that just a minute. All right, looking at the drugs. I've told you you're not going to have to name drugs, and you are not. You are not going to have to name drugs. We're not there. However, I do want you to have an idea when you see the name. So look at this name and see if you can find the different parts on that structure. Just look at the name and see if you can find why they call it that. What part do you think is the propanoic acid? Where do you think propanoic acid comes from? What does that mean? What do you think the oic acid is? What would be the oic acid? Guys, what's the only functional group that could be? Say it again. Carboxylic acid. Yes? Where is the carboxylic acid in this compound? Left, right, middle, down, top, what? Do you see it? How's it written? Do you see the COOH? So this is the carboxylic acid. Now, what would pro be, the prop part? How many would that be? 3. Look. Do you see 1, 2, 3? What do you think that would be? If you just had those, what would that be? Propanoic acid. Why? Because these 3 C's are bonded how? Are they bonded, single bonded to each other? So that is propanoic acid. So this is the propanoic acid portion. The carboxylic acid is in the propanoic acid, which makes it have the oic acid name. The prop part is 3 carbons. That's why it gets the prop, and they're bonded, single bonded to each other. What have I told you that the benzene ring can have a name of? What are some different names the benzene ring can have? One of the first 2 pages of these notes. It could be aromatic. But look under where we went through every functional group. Look at the page where we went through every functional group and tell me what the name could be. What do we call it? Well, it's not a cycloalkane. Well, I guess it could be a cycloalkane, but it's not. Actually, it's not an alkane, period, because it's got the double bond. Look at the name. Look at where we started. It said alkanes, alkenes, alkynes. Now, do you see that? What's it say? Benzyl, phenyl. Do you see those? Now, look at this name. What do you see? Do you see benzene in it? So this is, we would call it benzene, but the name is what? There's the phenyl part. There's the phenyl part. So here's the propanoic acid portion. This is the phenyl portion. Now this is crazy right here. Methylpropyl. What does that indicate to you? There's one methyl, which is usually CH3. Doesn't necessarily have to be CH3. Methyl per se just means one carbon. And then what's propyl? 3 carbons. This is one carbon, but if I were to spread this out, what would it look like? Where would these CH3s be? Both of them are on who? Are they on that same carbon? Does that make sense? So this C is like that, and then there's another one like that. So those CH3s look like that. Now, when you do that, imagine, if you will, and it doesn't matter, you don't have to imagine this, but I think for some of us it helps. Instead of this CH3 being at the bottom, put it at the end over here. If you put it at the end over here, then is that a CH3, a CH, and a CH2? Is that a propyl? And then what would that be on this propyl? A methyl. Now that's really goofy to call it methylpropyl. You're not ever going to have to name something like that. You won't have 2 alkyl groups. Why did they do that? Because they are going back to the parent, and the parent is propanoic acid. Now your question is my question, those of you that are thinking. Who said propanoic acid was going to be the parent? I don't know. I can't answer that question. But whatever reasoning there is behind these names for these more complicated molecules, evidently the carboxylic acid, if there is a carboxylic acid, that is the trump of who, how, why, what is the parent. In other words, a carboxylic acid becomes the parent. So whoever's attached to the carboxylic acid becomes the parent. Benzene didn't become the parent. This group of carbons over here did not become the parent. The carboxylic acid became the parent. And then everybody is named off of that carboxylic acid. And then it becomes the numbering method, which is honestly looks really crazy. Now the 2-methylpropyl makes sense to me, because this is the second carbon of this 3. Does that make sense to you all? That would make it the 2-methyl on the propyl. And then the rest of these 2s and 4s, I mean, there are definitely things I can see why it is 2, but part of it I don't understand, so I'm not even going to try to explain it. Do I expect you to be able to name that compound? No. Did everybody make sure they heard that? Because I know somebody's going to ask me next Wednesday, do we have to name something like that? No. You are not going to have to name something like that. Should you be able to recognize and dissect it like we just did, other than the numbering? Yes. You should be able to do that. Especially see the carboxylic acid and the propanoic acid, especially see the phenyl. This is a little trickier. Yes, most of you should be able to do that. Okay? It's fun if you'll let yourself have fun. I think that's part of the problem. You've got to just say, I'm going to enjoy this because what do I have to lose? It's 2 weeks left. Enjoy it, okay? And find the neatness in it and the coolness. Cycloalkanes are nothing more than adding cyclo to the acyclic name. So in a 5-carbon compound where they're all put together, it's not pentane, but it is cyclopentane. And so back here it was the 4, cyclobutane, cyclopropane, cyclohexane. Is cyclohexane the same thing as benzene? No. No, no, no. Guys, let me say that again. Cyclohexane is not the same thing as benzene. What's the difference? There's no double bonds here, are there? That's why it's different. This is cyclohexane. This is benzene. Big difference. The double bonds make a huge difference. This is an alkane, this is an alkene with alkanes, which is nothing other than benzene or an aromatic. Don't get those two confused. They don't look the same. Don't let them look the same. They are not the same. How do we name? How do we name these cycloalkanes? First of all, you get to pick who is number 1 based on where the substituents are. Wherever the substituents are, that's a 1. How do you, if there's more than 1 substituent, then you pick number 1 being the lowest alphabetically. Okay? So in this case, who is this? Ethyl. Who is this? Propyl. So this is ethyl, this is propyl. Who comes before in the alphabet? Who comes first in the alphabet? E. So E is 1. Then you number so that the rest have low numbers. So that's why you don't go 1, 2, 3, 4, 5. You go 1, 2. And so the name is 1 ethyl, 2 propyl, cyclopentane. The mistake that I wanted to make when I started doing this, I wanted to look at this and say, well, it's 1, 2, 3, 4, 5, 6, 7 carbons. You see what I'm doing? I'm putting the separate substituents in with the ring and trying to create this long continuous chain of carbons. Why can't you do that? I mean, wasn't that one of the rules? It was, find the longest parent chain of continuous carbons. Here's why it isn't right. If you have a cyclo compound, that's the parent. That is the parent. Now, I'm not saying benzene is the parent because we found out up here benzene was not the parent. But if you have a cyclical compound, that's the parent. And whatever is on that, even if it's longer than the cyclical parent, the parent is the cyclical compound and the others are the alkyl groups. That's why we do it that way. Now, to show you my stupidity when I was doing these notes, I guess I should definitely have taken this out for the video, but I didn't. I didn't take the time. Look what I put as the sample problem. It's exactly the same thing. Wasn't I a bright, smart little cookie? I'm telling you, you just have no idea how stupid I am. Those of you that think I'm intimidating, now you know I really am not. She was really dumb when it came to organic. But I'm going to fix it for you. Let me fix it. Let's make it something you don't have. Scratch out that CH2, scratch out that CH2, and come over here and put F. Now, see what you come up with. You number so that alphabetically, the one that will come first in the alphabet has the lowest number. Make that number 1. And then number in the direction so that the next substituent has a low number. So who's going to be number 1? Who is that? Ethyl. So this is ethyl. This will be 1. Which way do we go? Left or up? You go up. Why do you go up? Because if you go up, then this becomes 2, and that's a substituent. If you went left, it would be 2, 3 before you had a substituent. Okay? Who is this? Methyl. And who is this? How do you write it, though? Fluoro. And then who's the parent? Cyclopentane. So now put them in order alphabetically. Not numerically, but alphabetically. It may work numerically, but it's for sure alphabetically. Who comes first? So how do I do it? 1 dash ethyl dash 3, nope. Look at my numbers. I didn't finish numbering. 1, 2, 3, 4, 5. So what is it? 1 dash ethyl, 4 dash fluoro dash, come on, 2 dash methyl cyclopentane. Yes or no? Talk to me. Making sense or not? Yes. Yes. Her question was the reason methyl's last is because it's in alphabetical order. All righty. Flip the page. Now, the method to the madness on these notes. What we are doing is going through, and I've already gone through every one of the functional groups. Now I'm going through the functional groups and or biological molecules in more details, and or telling you about some interesting things that have to do with some of the functional groups. So it's kind of like we've looked at every functional group, and now let's look at them, the ones that have something interesting about it, or the ones the interesting things that I thought were interesting, pull that out, and let's look at it. That's what I'm trying to do. This is all about alkanes. Now, why do I say this whole page is about alkanes? Well, it looks like it's about fossil fuels, but what does it say fossil fuels are made up of? Somewhere in your notes. Carbon and hydrogen, but which functional group that's not really a functional group? Hydrocarbons describes 4 different groups. What do hydrocarbons describe? Alkanes, alkenes, alkynes, and aromatics. All of those are hydrocarbons. Which of those are the special hydrocarbon that make up fossil fuels? Alkanes. If you go back in your notes and look under alkanes, it says alkanes are the principal compound in fossil fuels. It says that, okay? Alkanes are the principal compound in fossil fuels. What does that mean? That means that every fossil fuel, coal, natural gas, petroleum. I'm not sure if propane is considered a fossil fuel or not, to be honest with you. I need to look that up. But for sure, the coal, natural gas, and petroleum, what do they have as their primary component? Alkanes. Now, are we saying that it's specifically pentane? No, I'm saying it contains alkanes. What does that mean? They're all carbon single bonded together. That's what I'm saying by saying that they contain alkanes. They're single bonded carbons. That's what they contain. And what we are going to spend most of our time discussing now are just simply petroleum and the products made from petroleum. Oil wells, Beverly Hillbillies. Nobody knows what I'm talking about? Up from the ground came a bubble. You got it? Okay, up from the ground came a bubbling crude. If you haven't seen the Beverly Hillbillies, that's the part of the theme song at the beginning of it. What's coming up out of the ground? What kind of oil? What's it called? I already said it. People call it crude oil. Why do they call it crude oil? It's not refined. What is that picture of A there? A refinery. If you've ever been to Texas, Houston, you've seen these. Louisiana, you've seen these. Huge refineries. And what's really amazing about these things, and this picture does not do it justice. Your picture, if you'd printed it in color, it's a little bit better. But if you look at that closely, what is the number one thing you see in that picture? Say it again. Towers and what else are there lots of? Pipes. Do you see all those pipes? And again, I know it's a hard picture to see. But there's tons and tons and tons and tons of pipes. Why are there so many pipes? Because petroleum makes a lot of different products. The picture on the far right, crude oil, and this is talking about it, a refinery tower. As crude petroleum is heated, the lower boiling components come off at the top of the tower, followed by fractions of higher boiling point. This process is called fractional distillation. When I was in college, I took organic chemistry my junior year, and that was the only year in college I ever played. That was my mistake. I went on too many trips that semester, and I didn't get it. But when we got to this point in the class, I remember thinking to myself, this is really cool. I wish I'd paid more attention all semester, because this was really interesting to me. Because I started looking at this, I'm like, it amazed me that one product, that stuff that comes out of the ground, and I've had the opportunity, my dad, he has some oil wells on his farm. And so I've seen crude oil. I mean, we used to go check the tanks. I mean, you go look at the crude. I've seen it coming up out of the ground, and there it is in the tank. I've smelled it. I know what it is. And to think that's what gets made from it. How does that get made from it? Well, let's talk about distillation real quickly. What is the process of distillation? Can anybody describe distillation to me real quickly? Anybody, can you tell me what distillation is? No, that's not distillation.
When I think of distillation, I think of like a distillery.
You're thinking of a distillery of alcohol. Now, let's talk moonshine. I don't drink moonshine, but everybody always thinks that I'm drinking moonshine when they see me out. They tease me about my moonshine jar, because that's what you used to see people have, was their moonshine in a quart jar. The process of distillation is not making alcohol. What is the process of distillation for? In alcohol, what it's for? But what's the purpose of distillation in the making of alcohol? It's not the making of the alcohol, it's the purification. The fermentation is what makes the alcohol. Now, I have never made alcohol on purpose, but baking bread, you make alcohol. If you ever leave apple cider in the refrigerator or on the counter and leave it there too long, you make some alcohol without meaning to, or maybe you do. That's called hard cider. The fermentation, have you ever had any apple cider? This time of year this happens. If you had the apple cider too long and you go to open it up and it it pops off the lid, you've made alcohol. You've made some hard cider. That's what you've done. Now, let's say that I'm making moonshine. Now, I've never made moonshine, but let's say I'm making corn whiskey. That's what they might call it, okay? You take your corn, you're going to add yeast to it, and you're going to have the fermentation of that, and then you get rid of all of the junk. That's not what you want. You want the liquid portion. That's where your alcohol is. So you would filter out, you're settling, that would be more filtration. You would filter out all the corn, what they call the mash. You'd filter all that out. Then what you'd be left with would be this liquid. But what does your liquid contain? It doesn't just contain alcohol. It contains sugar, water, other stuff, right? But if we're making moonshine, we want alcohol. So how do you get the alcohol? That's distillation. That's where distillation comes in. What's the boiling point of water? 100 degrees Celsius. Will alcohol boil at a lower temperature or a higher temperature? Think about which one would evaporate faster? Alcohol or water, which would evaporate faster? Alcohol. Which one has a lower boiling point? Alcohol. Alcohol. So what are you going to do with your watery alcohol mixture? You're going to heat it up, but are you going to heat it up to 100 degrees Celsius? No. You will heat it up to the boiling point of alcohol, which I believe is in the 70s or 80 degrees Celsius range. So it may even be lower than that. Why don't you want to heat it up to the boiling point of water? You don't want your water to boil. What's the whole beauty of moonshine? I don't know because I don't drink it, but I think it's to get pure alcohol. I think moonshine is some really hardcore stuff. It's a lot of alcohol. You don't want much water in your moonshine, right? So you try to get the temperature just to be the temperature of the alcohol. Now, what does that still look like? No, the machine per se. Come on, you've seen these before. I'm not talking about oil. You've seen these in the movies, the old shows, Beverly Hills, not Beverly Hillbillies, the Waltons. Come on, have y'all, any of you seen these old shows? None of you. Like barrels and copper piping, thank you. Have you seen those rolls of copper pipe? Guys, watch some old TV shows and get off the internet.
My great-granddaddy.
Good. Thank you. We got some historical information here. All right. So it's those two. Have you ever seen a real one? The pictures?
Yeah, I wasn't around.
So we have these tubes. Now tell me what copper does. Does it conduct heat? In other words, copper gets cold fast and it gets hot fast, right? So here's our container. Here's our vat of boiling alcohol, but our water's not boiling yet. But what's that alcohol doing? Changing from a liquid to going into these copper tubing, and it's air cooled. That's why there's so much tubing. And if you ever see a picture of one, the copper tubing starts up here and then it comes down. Why would that be? Gravity flow. It's not water. What is it? It's our alcohol. So our alcohol vapor is in these tubes, and as it travels through these tubes, what's it doing? Cooling down. And as it cools, what's it change from? A gas to a liquid. And drip, drip, drop, there it is. No, it's not. It's water. But does that make sense? Now, take that process and go to black crude oil. How many of you have ever seen or smelled real natural crude oil? Very few of you. That's what I was afraid of. Okay. Have you seen the pumps out in the field? They go up and down, up and down, up and down. Nobody's seen these? You may not have known what you've seen. If you go down the road and you've ever seen a tank, a silver tank in a field, And then there's this, it's like a bar stick. That's not right either. What am I thinking of? Not even a rod, just a big piece of metal or wood. It's just like a, what am I thinking of? Like a lever. So it's just, say, a rectangle piece of wood or metal. It's at least as long as this table, half this or 3/4 of this, shaped about like this here, long, and it goes up and down, up and down, up and down. Some of you have seen these. If you see that thing going up and down, and there's a tank nearby, you've seen an oil well. Now, some of you have seen what I'm talking about. If somebody can describe it better than I did, please do, because I know that was not the best description. Okay? Some of you have seen these. Now, that people call it black gold. Guys, what you need to understand, and that's one of the things that I find out, that you guys have so much knowledge about certain things, but some things you don't. And I'm the same way. There's certain things I have no idea about. And it's interesting to me, the things I know about, you all don't know about. There's things you all know about, I don't know about. I don't know anything about Twitter and Snapchat, and I don't understand any of that stuff, but you all could explain it to me. But let's go to this oil. It comes out of the ground. We fight for it, people. Do you realize that? Why have we allied with certain nations? Because they have oil. They have oil. Even within this country, recently, part of the presidential election was all over whether we were going to have the pipeline going into Alaska, coming down through the United States. Why is it all this big deal? Because take that crude oil, put it in that refining tower. Our room temperature right now is approximately 23, 24 degrees Celsius. If I brought in crude oil right here, there are gases coming off of it in this room that are collected and used to make things. Then I heat it up from 20 to 200 degrees Celsius, and look what I get. Gasoline. Heat it up a little bit more, what do I get? Kerosene. Heat it up a little bit more. That's called like jet fuel. People like to fly, don't they? Heat it up a little bit more. That's called get your oil changed. Lubricating oil. Hydraulic fluid. And then you like to drive? What's on your road? Now, when you've smelled the smell of freshly laid asphalt, you know that pungent odor? Some of you like it, some of you hate it. That's crude oil. That's the smell of crude oil. Okay? Tar is similar to the asphalt residue. But you can also have a tar pit without petroleum. In other words, you can have a tar pit that may not necessarily have petroleum that could then be used for asphalt too. And that, well, the Beverly Hillbillies is different than that. They found crude oil and went to Beverly Hills to live. Have you ever seen that show? Oh, you need to see that show. But I did not know that that tar pit was in Beverly Hills. That's interesting. But that would be, I don't know my geology, but my assumption, which is probably wrong, is that that may be where, you know how the whole fossil fuel thing is because of pressure and compaction and da-da-da-da-da. That one may not have gotten fully processed into the petroleum, but it's still in the family. It would still be in the family, yes. Oh, really? Does it have a smell? Okay. Yeah. Yeah, that's interesting. All right, so now if this is just what we're seeing right there that comes off of the petroleum during fractional distillation, does that help us understand all those pipes? Do you see the pipes that are coming off of these? So now imagine this in a big setting like in Houston or Louisiana where this is. The pipes are amazing. I mean, it's just insane, all the pipes. It's like, how can you keep up with all those pipes? Because they're everywhere. Now, take this, and in 1 barrel of crude oil, this is breaking it down even more than that does. In 1 barrel of crude oil, this is approximately what we get out of it. About 20 gallons of gasoline, 8.5 gallons of diesel or home heating oil. Most of you don't use heating oil in this part of the country for sure. Diesel's what I use in my tractor. Diesel automobiles you know about too. Jet fuel, lubricants, waxes, solvents. This is like paint thinner. Waxes, all kinds of waxes are made from. It's like paste wax. You may have floor wax, all those different waxes. Boiler oil, asphalt and road oil, and then this one is amazing. Petroleum starting materials for chemical synthesis. And they pulled that out, and look at that picture. What do you see in there? How many of you have a plastic water bottle, use Vaseline, have had a rubber ducky, and use compact disc and Sharpie markers and sunglasses? Every one of you. There is not one person in this class, I would bet $100, that does not have something on them right now from crude oil, that somehow came from crude oil. Even if you're the most natural person in the world, chances are you have something on you from crude oil. Now, does that explain a little bit about why we fight for crude oil? Are we dependent upon crude oil? Pretty amazing, isn't it? So when it comes time to make those decisions, think back about this. Would it be better to use crude oil from other countries, you think? Or us? Or don't use as much? Are those all questions that have to be answered and that are being answered? I mean, think about that. Do we get it from other people? Do we have it here, or we use less, or a combination of all those? Isn't that interesting, though? That's when you hear people talking about this, if you're not up on current events, this is why they're talking about it. This is why. Okay? Pretty interesting. I had told you the first time we talked about alkanes, I said something about their reactivity. What did I say? Do you remember what I said about the reactivity of alkanes? Not very reactive except under extreme, and then you've said it. What was that extreme circumstance? Fire, burning. Last chapter or last test, do you remember we talked about 2 different acid-base reactions, and I said that you had to know how to predict the products for those? These are 2 combustion reactions, and you need to predict the products for these. You will see these again. Now, I'm not saying that it's just this one and this one. I'm saying you need to know what the complete combustion of a hydrocarbon produces, and you need to know what the incomplete combustion of a hydrocarbon produces. So this is the complete combustion reaction. This is the incomplete combustion reaction. What's the difference between them? Complete combustion produces what? Carbon dioxide and water. Incomplete combustion produces carbon monoxide and water. When do you have complete combustion? When you have enough oxygen. Incomplete combustion occurs when you do not have enough oxygen. Now, I know some of you are saying, but it says we have O2. Don't we have enough? What I am saying is, in a real situation, let's say that you have a natural gas furnace in your house and it's burning methane, which is CH4. It's burning methane, and for whatever reason, you don't have enough oxygen in your house. What is the product going to be? Why is that dangerous? It's a poisonous gas. So, tell me, it's all right here. What does carbon monoxide do? What is the iron of the hemoglobin supposed to bind to in your body? Oxygen. But if carbon monoxide is present, who attaches to the iron of the hemoglobin? Carbon monoxide instead of oxygen. So in essence, is your hemoglobin suffocating? Yes, which in turn makes you suffocate. And the really sad, bad thing about carbon monoxide poisoning is they call it a silent killer. Why? What does it do? It just makes you sleepy. And it's odorless, it's colorless. You can't smell it. You don't know what's happening. You're just getting sleepy. Oh, I must not be feeling good. I'm sleepy. I go to sleep and you don't wake up. It's very bad for elderly and young children, babies. So if you have gas heat or wood heat, what should you have in your house? A carbon monoxide detector. And if the level of oxygen gets too low, it will go off and tell you, hey, you need to open a window and let some fresh air in. Most of your furnaces have oxygen sensors on them, and if there's not enough oxygen, it will shut the unit down. But you need a backup, and the carbon monoxide detector is the backup. You need smoke detectors too, okay? Both. You need both. All right, so tell me what we're going to put up there. For the complete combustion, tell me first, who is C5H12? Name it. Pentane plus oxygen, what's it going to produce? CO2, and because this one is complete combustion. Now methane plus oxygen yields what? This is incomplete. Plus, all right, balance those. All right, what do you get for complete combustion? Tell me the coefficients. If it is 1, just go ahead and say 1. I won't write it, but say 1. Good. So 1, 8, 5, 6. Good. What do you get for the incomplete combustion of methane? Everyone get those? Any questions on those? Guys, you will see these. This will be a test question. I will give you questions where you have to figure out the products for a reaction of an alkane. You'll have to do this. What's another word for combustion? I think you all know this, but what else could I have said here? Combustion of a hydrocarbon always produces energy, or what could I say? Come on, the easy word. What are we doing to these? Burning. You all were thinking too much. Burning of a hydrocarbon. Combustion and burning mean the same thing. And every time you're getting energy out. Every time you're getting energy. That's why we burn them, is to get energy. That's why we're burning them, is to get the energy. One last thing on carbon monoxide. I don't think I have very many smokers in here, but I do think there are some. You choose to smoke, do you realize that carbon monoxide is actually formed when cigarettes burn? Therefore, what are you getting in your bloodstream? Carbon monoxide. So you actually have the carbon monoxide binding to your iron of your hemoglobin when you choose to smoke. So realize that. You know, I don't smoke. My brother smokes, and smoking must just be so addictive because it's like everybody knows smoking's unhealthy. I mean, it's like proven your lifespan's going to be less. But people still do it. It must just be absolutely so hard to quit that. And I wish there was an easier way, but it is really unhealthy. If you do it, I hope you'll quit. The last two things down here are just some reminders. We've talked about this more than once. I told you that there would be two different names. I wanted you to know the old names, and this is what those are, the acetylene and the ethylene. Also, isopropyl alcohol is rubbing alcohol. We've talked about that as well. And that was the 2-propanol. And we'll see that again. All right. So, fatty acids. What are fatty acids? They are carboxylic acids with long carbon chains of 12 to 20 carbon atoms. What do fatty acids make up? Say it again. They are a component of membranes, yes. Cell membranes. Go with the common thing. And it's so simple, some of you are not even thinking. Read this page and tell me, based on what is on this page, just little words that you see on this page, what do you think fatty acids make up? Fats and oils. Okay, don't make it harder than it is. Big picture. Fatty acids are long chain carbon with a COOH on the end. 3 fatty acids put together make what's called a triacylglycerol or triglyceride. Have you heard of those before? All of your fats and oils contain fatty acids. There are saturated fatty acids and there are unsaturated fatty acids. Now, if you go a step further, you're going to say there's saturated fats and there's unsaturated fats. There's monounsaturated fats, there's polyunsaturated fats. Where have you heard the term saturated before? Well, I'm talking in this class. Where have we talked about saturated in this class? If it's, who's a saturated hydrocarbon? Alkanes. Alkanes were the only saturated hydrocarbon, and what did they have? C, single bond C, single bond C, and they're just smack full of hydrogens, right? So now take that thought and put it to saturated fatty acids. What do you think saturated fatty acids have? All single bonds in that carbon chain. What do unsaturated fatty acids have? At least one double bond. Does that make sense? What does that matter, you say? Well, the number of double bonds makes a change in the melting point. And so those saturated fatty acids with lots of double bonds have a lower melting point, which means what are they going to be at room temperature? Liquids. If they have a high melting point, then at room temperature they're going to be a solid. Now, go in your brain and just tell me anything you know about fats and oils and health. Don't need much of it. We don't need much fat or oil. That's at the top of the pyramid, the real little tip. There's what we call healthy fats and unhealthy fats. Of the two, who do you typically hear is more healthy? Solid fats or oils? Oils. Now, where is that leading you? Oils contain, what do you think? Saturated fatty acids or unsaturated fatty acids? More unsaturated fatty acids. See, you knew all this without knowing you knew it. Now, let's put some words down. So, saturated fatty acids have only single bonds between carbon atoms. Unsaturated fatty acids have one or more double bonds. Excuse me, between carbon atoms. I don't want you to get confused like I did about the double bond. Every one of these fatty acids have a double bond. But where is the double bond in every one of them? Not between carbon atoms. Every one of these, even the saturated, have a double bond. Where is that double bond? Say it.
Carbolic acid.
Carboxylic acid, meaning where is it? C double bond O. You with me? Don't let that confuse you later. So when I say one single bond or more or no single bonds, I'm talking specifically where? Between the carbons. In that 12 to 20 chain of carbons. So if I have C single bond C all the way down to C double bond OOH, then that is what? Saturated fatty acid. If I have C single bond for 5 and then all of a sudden a double bond and then single bonds to C double bond OOH, then that's an unsaturated fatty acid. And then I could have 2 or 3 and it's still unsaturated. Does not count. That's what I'm trying to say. Every one of them have that because of carboxylic acid. Don't let that confuse you. This is C double bond O OH, but it's not the double bond I'm talking about. It's these C's are all single bonded. Those are all single bonded, which means when it says over here 0 C double bond C, what's that saying to us? No double bonds. So it means, what is this fatty acid? Saturated. So this one is considered to be saturated. Oleic has 1 double bond. Linoleic has 2. Linolenic has 3. So that means each of these is what? Unsaturated. And where you have heard the term monounsaturated, that just means it has one of those. If it has polyunsaturated, then that means it has many double bonds. What do you see happening as the number of double bonds increases? The melting point decreases. And I'm also going to add another statement. The more double bonds, the greater likelihood of liquid at room temperature. The more double bonds, the greater likelihood of liquid at room temperature. Look at stearic acid. What is its melting point? 71 degrees Celsius. Now, earlier I told you room temperature, this morning, I'm going by this morning, the room over in Central Wing, it was 24 degrees Celsius. So let's say room temperature is 24 degrees Celsius. At room temperature, what would stearic acid be? Solid or liquid? Solid. If I heated it up to 71 degrees Celsius, it would become a liquid. Everybody with me? But oleic, linoleic, and linolenic would all be what? Liquids. Do you see that? Because their melting point's below room temperature even. That means at room temperature they would all be liquids. Fats and oils. All fats and oils are made by either plants or animals. And that, you think, well, that, of course they are. That's the only thing that possibly could make them. But you know where my problem comes in? I don't think of plants as being fats. Think about, what do we think of plants as being? Healthy. I mean, you all said the word that everybody, that's what you're, well, they're healthy. Fats unhealthy, plants are healthy. I mean, that's like we've got this thing in our head. Olives are a plant food, or they are made from plants. What are they? Very fatty. What makes olive oil? Olives. Peanut oil is made from peanuts. Peanut butter is very fattening. Okay, but does that mean it's terrible for you? No, peanut butter is an awesome food for you. It's high in protein. It's got all kinds of good stuff in it. Coconuts. I was hoping you'd hold off on coconuts. Let me talk about coconuts in a little bit. They are a plant, and we do have coconut oil. Let's hold off on talking about coconut oil for just a minute, though. Tell me which plants you know of that produce oils, besides the ones I've named. Almond oil, safflower, sunflower, avocado oil. I didn't know they made avocado oil, but avocado definitely is a very fattening food. Vegetable oil, if you go to the grocery and buy vegetable oil, it's soybean oil. But it is called vegetable oil. But it is soybean oil. There's two that I thought you would say you haven't said. Canola oil and corn oil. All of those are from plants. Now, a little agriculture lesson here for you for a minute. The corn oil that you see in the grocery store, is that the same corn plant that produces the corn that you and I eat? No. Think about that for just a minute. The corn that you and I eat is what compared to that? Sweet. Some of you're almost saying it, but you were scared to say it. It's sweet. We eat sweet corn. This is what's amazing about plant genetics, what they have been able to do. How many different varieties of corn are there? I have no idea. But just if I think of the traits of corn, you've got your corn that makes corn chips. Of those, you've got white corn chips, you've got yellow corn chips, you've got blue corn chips. Do you realize that? Then, and that's not a sweet corn, is it? No, corn tortillas. Similar corn, would you agree? Okay. Now go corn, summertime sweet corn. Sweet, sweet, sugary, sweet. Good stuff, right? And then we go goat, chicken, cow corn. Horse corn, like my dad said. That's what grows in this part of the country. That corn is not very sweet. It has some sugar, but not nearly like the sweet corn. And it's got a little fat, but nothing like then there is corn that makes corn oil. Now think about that. Isn't that really wild to think the corn that makes corn tortillas, we don't think of those as being, I mean, they're not like oily. I mean, yes, they are fried, maybe a few of them baked, but overall they're fried. So they're fried in some kind of oil, but the just corn flour, have you ever had just cornmeal? That's not fatty, is it? Doesn't seem fatty at all. But yet corn oil is a fat. That's just a few of the different varieties of corn. Canola is a plant that's grown out. It's a grain. They press it and make oil out of it. That's canola oil. It's grown in this part of the country now, by the way. Hopkinsville. Anybody live in Hopkinsville or from that area? There's a Hopkinsville. They are now refining canola oil in Hopkinsville. That's why it's being grown more in this area. Soybeans that we grow here that are being harvested now, when you look out in the fields and you see that brown stuff that you're like, what is that in the field? That's soybeans. Many farmers are trying to get done before Thanksgiving with their soybean crop. That is soybeans. Those are soybeans that are used for animal feed. Not much of those soybeans are used for oil. But are there soybeans that are used for the vegetable oil? Yes. So it's an amazing the number of different varieties that are all different for these different purposes, and they all have different traits. In general, oils, I've kind of already answered this. In general, oils, unsaturated oils are common in what kind of sources? Animal or plant? I've said it, guys, like 20 times. Plants. Saturated fats are typically obtained from what sources? Animal sources. And I said here the exception's coconut oil. I'll come back to that one. So let's talk about what we mean by fats and oils. Fats, we say, are solids at room temperature. What are oils? Liquids at room temperature. Fats in general generally formed from saturated fatty acids with a few unsaturated fatty acids. What do you think oils would be formed from? Generally formed from unsaturated fatty acids with a few saturated fatty acids. I want you to realize, though, all fats contain both. All fats contain both saturated fatty acids and unsaturated fatty acids. They contain both. So don't let somebody convince you you cannot eat butter. It will kill you because it only has saturated fat in it. That's not true. Butter has saturated fatty acids. Yes, I would agree. But does butter also have unsaturated fatty acids? Yes, it has both. Olive oil is the only healthy fat. No, that's not true. Is olive oil healthy? Yes. What if I drank a gallon of olive oil a day? That would be gross and unhealthy. It's all relative. Olive oil has unsaturated fatty acids, right? But does it also have some saturated fatty acids? Yes, they all contain both. That's what I'm trying to say. Now, to give you a little experiment to try, maybe you've done this before or know somebody who has without knowing they did the experiment. You can get an idea of which is the bigger percentage comparing different oils by putting them in the refrigerator or freezer. Give you an example. Let's talk about the fats first. Give me some examples of fats. I've given one tonight. Say it again. Crisco would be one. That is definitely an artificial fat, and we'll talk about that in a minute. It's not a natural fat. That's a man-made fat. Give me more details. Butter. Lard. Pig fat. Lard is pig fat. Lard is pig fat. Grease. I want to define your word grease. You make bacon. Bacon grease is lard. You call it bacon grease, it's lard. That's what bacon grease is. It's flavored lard. And they do sell lard in... Yes. But you make biscuits with it. Biscuits are made with lard. Most of your great-grandparents. Guys, I want to explain something to you. Crisco is the man-made version of lard. You think lard's gross. I think Crisco's gross. Crisco is taking vegetable oil and through a process of what is called hydrogenation, they actually break the double bonds of the unsaturated fatty acid and add what to it? What was the word? Hydrogenation. What do you think they add to it? Hydrogen, and make them single bonds. So they're taking a natural oil but making it unnaturally solid. Lard just happened to be naturally solid already. Now, our tastes have changed over the years. Your grandmother, great-grandmother would never have thought anything about having her lard can, picking it out with a whop and putting it in her biscuit batter or to make her pie crust. You guys, you can't imagine using that stuff. But you'll go get Crisco and use it the same way. It's the same thing, except one was from pig fat, the other is from oil that chemically was made solid. Okay? They're similar but different. What you called grease, I'm going to call tallow. How many of you ever heard of the word tallow? Nobody's heard of tallow. You've heard of it. Thank you. At least you've heard of it. I really need to educate you all. Tallow is the fat of sheep or cattle. Now then, found this out this morning. This cracked me up. I'm talking about making a roast. Nobody knows how to make a roast. That's what I was finding out in my class this morning. So I made this offer. If you know nothing about cooking and all this stuff that I talk about is totally foreign to you, after the semester is over during Christmas break, send me an email and I'll let you come over and we'll talk. I will let you cook. We will learn about real world living, okay? I will not do that while you're my student, but after you're no longer my student, I'm really serious. If you are totally like, I have no idea what that woman is talking about. She like lives a different world. Come and I'll bring you to my world, okay? I've never made that offer before.
I'm sorry, this is like kind of off. Anyway.
Okay.
Have you ever like killed a hog?
I have.
Okay, well I'm actually killing a hog with one of my family the day after Thanksgiving, and like lard that you get from killing a hog is like 10 times healthier than the lard you buy.
Why do you say that?
Because like it doesn't have all.
That's like saying the pig that you're killing on your farm is healthier than the pig that you would buy in the grocery store. That's what you're saying. I'm going to look at the weather for you. That's what I'm looking at. Is it supposed to be cold?
I think it is, yeah.
Where are you from?
I'm from Grayson County.
Okay. You said you're doing this on Friday? It is going to be too warm for hog killing that day. Yeah. Do you have to do it that day?
I don't know.
It's 57 degrees.
Really wants to kill.
You tell them to wait. They tell them seriously, wait. You need to do that in end of December or January. You can't do it. It's going to be 57. It is way too hot. Because you have to cool that meat down fast. You can't have it warm like that. You'll spoil. Seriously.
Yes.
Have they ever done it before?
Yeah.
Well, they know that, surely. Surely they know.
He was hoping that it was going to be cold.
I don't think it's going to be cold enough. You let us know, though, when you come back Monday. But I don't think it's good hog killing weather. Now, that is hilarious because I grew up and we killed hogs. The whole family, we killed hogs.
Yeah, the whole time you were talking about lard.
That's what you were thinking of.
It was disgusting. Like, my grandma cooks supper every Sunday, and all she uses is lard.
She fries her chicken in lard.
Everything is fried in lard.
Yeah.
I know.
And Cheyenne knows because she's thrown hair dryers into the...
Oh, geez.
All right, so let's have a little lesson here, okay? Let's have a little lesson. All right, so lard, real quickly on her scenario here, what she's saying is that the lard from her hogs is healthier than the lard you buy in the store. That's the same thing as saying her pork chops are healthier than the pork chops you buy in the store. Why is she saying that? Because she knows what's gone into her hog that's going to be killed, whereas the animal that you buy at the grocery store, you don't necessarily know what went into that. Now, let me warn you, that does not mean the one you buy at the grocery store is unhealthy. There is a big fear tactic of a group of people, I don't know what you want to call that group of people, but there is a group of people that love to scare people and say, you should not eat chicken produced by Tyson or Purdue because it's grown in a chicken house and those poor chickens can't get outside. There's a group of people that will say, don't eat pork out of the grocery store because those poor pigs can't ever get outside. There's that whole group of people that say, don't go buy beef from the grocery store because those poor cows have never seen sunshine. That is a fear tactic. Guys, production agriculture feeds this nation and a lot of other countries. I don't think very many of you are going to go raise your own hog, raise your own chicken, and raise your own pig or beef. So if you aren't going to do it, how are you going to eat it? You're going to have to depend on the United States producing good meat for you. So please don't get scared of the meat at the grocery store. Now, are some of the animals given too many things you might not want to consume? You may feel that way. That's your prerogative to feel that way. But don't fuss about it until you know how it's raised. Because until you've been there and done that, you don't know what you're talking about. So go to the chicken house, find out how the person's raising the chickens if you want to fuss about chicken houses, okay? Don't just assume they're bad. I've raised chickens on pasture before, and it is not fun. Chicken houses are good places for chickens because those particular chickens are bred to be fat, lazy eaters. They need to be in that chicken house, which is the perfect little environment for them. They don't thrive on pasture like I tried to raise them. That's because they're made that way, okay? It'd be like putting me out in cold weather constantly. We're not made to sit out in cold weather constantly. Now, you take an Eskimo, they're made a little differently than me, right? Not much, but some. So, there's a difference. Now, the fat we're talking about here, I'm going to deal with the three naturals. Butter, lard, and tallow are the natural fats. Butter is from what? Milk that has been churned, whole milk that has been churned. You can make your own butter. If you go buy cream, Put it in a jar and shake, 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 and you can get some butter. And that will make your butter, okay? Lard is from the pig fat. Bacon, that's lard. When you fry your bacon, the grease that's left over is lard, except it's got flavoring in it because of the bacon. Tallow is from beef or sheep. That's what the fat is called. Now, where I was going with this, which we went farther, and that's okay. A roast. Let's say that you make a chuck roast, a beef roast. You make a beef roast. You put your beef roast in your pan, you cook it, you come back, you eat it, and you set that pan in the refrigerator. Next morning, you come back, you open up the pan. What do you see inside the pan? White, hard layer on top. How hard is it? It's really hard. What is that? That's beef fat. That's beef tallow. Now, if you did that same thing with a pork roast or say a Boston butt, some of you you know what I'm talking about if I say Boston butt or pork shoulder, you go cook that, you leave it in the pan, come back the next morning, open it up, it still has that white layer on it, but it's softer. Now, what does that right there tell you? The pork fat has more unsaturated fatty acids than the beef fat, the beef tallow. Do you see what I'm doing? Now, you can take that same experiment and you can do that with oils. So we already mentioned a lot of oils. I'm just going to real quickly throw these down here. Olive oil, corn oil, canola. All of those are your different vegetable oils. I mean, you could go, there's a ton of them there. You could just list all kinds of vegetable oils. Take those oils and put them in your refrigerator. Olive oil put in the refrigerator will get it won't get as hard as the beef fat, but it gets close to that lard. It gets really solid. Corn oil, put it in there. Canola oil, put it in there. By doing that, you can get an idea of which ones have more saturated fatty acids and which ones have more unsaturated fatty acids. Do you see what I'm doing? How? How does that tell us? Because if it's really hard at refrigerator temperature, then that means it has a lot more saturated fatty acids and fewer unsaturated fatty acids. Now, go a step further, take that and put it back on the counter and let it warm to room temperature. Take each one of those and let them warm to room temperature and then see if they're still solid or not. If they turn back to liquid, then that tells you their melting point is, you with me on what you're doing? And all you're doing is using the refrigerator, and that gives you an idea. Now, what is that really telling you? It's not telling you anything more than the approximates of fatty acids, meaning which ones are saturated, which ones are unsaturated, and what's in them. But my whole point is to explain to you, do not think that all solid fats are only saturated fatty acids, all liquid fats or oils are only unsaturated fatty acids, because that's not true. They contain a mixture. They contain a mixture. We talked about Crisco. Let's talk about it real quickly here. I've already said these words. The food industry adds hydrogen to oils in the process of hydrogenation in order to make the oil a solid. It makes the oil a solid. Now, the process of hydrogenation. Hydrogenation, I want you to write this down. It is an addition reaction in alkenes where the C double bond C is broken and hydrogen is added. It's an addition reaction in alkenes where the C double bond C is broken and hydrogen is added. if you read your food labels, many of your pastries that we love to eat, those of you that are thinking, oh, lard would be absolutely gross, guys, those pastries, if you'll read the labels, like donuts, they're going to say they have hydrogenated vegetable oils in them. They're going to say that. Used to, they'd have lard in them. Now they're going to have hydrogenated vegetable oils in them. Here is the problem with hydrogenation. It's not, you don't see this as much now as you did a few years ago, but do you all remember probably when you guys were freshmen to sophomore in high school, some of you that are freshmen now, you would go to McDonald's or other fast food restaurants, and there would be somewhere it would say no trans fat. Do you remember seeing that? Trans fat is the bad fat that occurred from hydrogenation. And it did the same thing to your blood fat levels, your blood cholesterol levels, your blood triglyceride levels as saturated fats. So they were promoting these hydrogenated fats as being healthy, quote, healthier than lard, but they really weren't necessarily healthier because they were doing the same thing in your body. To give you a little bit of an idea of what they are, I'm not going to go into great detail on this, just real quick, giving you a little idea. First of all, we all should remember when you have a double bond, it can be broken. And does that free up 2 electrons? What can be added then? If it's hydrogenation, what's added? Hydrogen. So then does that make it all single bonds? Yes. Okay. Now imagine, if you will, let's take this linolenic acid. This shape, do you see how this shape has all of the hydrogen at the top with the CH2s at the bottom? This is what we call a cis bond. A trans bond is when this is flip-flopped. And what happens on a trans bond is it ends up looking like a stair step. And so then these trans fats, instead of being where they can't line up with each other, the trans fats, because they were kind of like a stair step, they could line up with each other, which made them more solid, which is what they were trying to do. They were trying to make them more solid. Now, let me go that route for just real quick. What would be the purpose of a solid fat versus a liquid fat in the food industry, fast food industry? All your French fries are what? Fried in fat. Is it easier to transport a solid or a liquid? Probably a solid. Would it be easier to transport that solid that's used for those French fries or the liquid? The solid. And so, hallelujah, they're thinking, wow, we've got this great product. But it was actually causing the same problems as if they'd been using a natural saturated fat. The other thing that we like about solid fats is have you ever heard of the term satiety factor? Like if you're on a diet and you are only eating fruits and vegetables and hardly ever get any fat, do you feel full very often? You feel like you're constantly hungry, but if you throw a little fat in, it satisfies you more. Fats, we need fats. Our bodies need fats, and fats make us feel fuller. Fats, the different solid fats actually make different foods have a different texture, like donuts probably can't be made with oils. It just doesn't work. I know I make a pie crust with an oil. I have an oil pie crust. I like it. Some people, though, would never think of using an oil in a pie crust because they use a solid fat because they feel like the texture's not right. So different, that's all. You want a chemistry field that you get to eat? Go food chemistry, man. I mean, that's all of those different experiments that are figuring this out, all of that. And so what we're looking at is they were taking that hydrogenation, and what was happening is some of these cis bonds were converting to trans bonds, which then had that solid shape, which was good, they wanted that, but it did the same thing to your blood cholesterol, to your blood triglycerides. Now, real quick, what are blood cholesterol, blood triglycerides? What's the problem with them? We all have cholesterol, we all have triglycerides, but basically that blood triglycerides are fat in the blood. Now, what's funny, I wear my fat on the outside, but my husband is a thin person who's very muscular, but he has high triglycerides. He wears his fat on the inside. And so where's the problem with that? Well, let me explain the problem with it. I'm going to have a gross experiment. Take butter, melt it, suck it up with a straw. Don't drink it, just suck it up into the straw. As it drains out, immediately pick it up, pull it over into a glass of ice water and suck up water through it. What's going to be inside that straw? Solid butter. That's what's happening in your blood vessels if you have high triglycerides. So what's happening over time if you have high triglycerides? Clogging them up. And then what happens? Changes your blood pressure, your heart has to pump harder. Does that make sense now? So the problem with all of these that increase your blood triglycerides, that's the problem with it. So that's where they found out. And this is not the right page number, but you could definitely, if you are interested in that cis and trans, look up that in your book that you've got now. That's not your page number, but look it up. And that's pretty interesting. All right, flip the page. This is nothing more than a fun little article to read in your spare time while you're sitting in the bathroom after eating turkey. And you can read all about butter and why it's been scrutinized and all that good stuff. But really, why did I give you this? Well, actually, I use butter. That's one of the reasons I gave it to you. But it was interesting to me. I got on a tangent there. But here's why I really gave it to you. What's this showing us? What are these things? Fats. And what's it telling us here? The whole point is, I've already said it more than once. All fats and all oils have combinations of saturated fatty acids and unsaturated fatty acids. And that's what I want you to realize. It's not like all lard. In fact, lard's really kind of funny. But it also, this right here, our experiment, my little experiment I said to do in the refrigerator, proves this right here. Why? Which one is harder in the refrigerator? The beef tallow. What does it have more of? Saturated fatty acids, but the lard has fewer saturated and actually has more. Now, what does it mean monounsaturated? One, whereas polyunsaturated means it has more than one double bond. Okay, pretty interesting though. Again, nothing major, just look through it. All right, let's talk about polymers. Around this time, some of you are decorating a Christmas tree, and some of you are going to make polymers for your Christmas tree. Well, you probably won't, but some of your smaller friends might. Younger, smaller friends. Did you say what I thought you said? What'd you say up there? Somebody said something. Okay. I heard ch. Ah, you got it now. Little paper chains? Those are polymers. Those are polymers. That's what you need to tell your little cousins. You made polymers for the tree. How cool. What? Yeah. Well, what is a polymer? Polymer. Mini-mer. Mini-mer. It's mini-mers. What's a mer? Well, a monomer is the single unit, and many of them together is a polymer. And polymerization is the process of joining together of monomers to make polymers. Now, who are our polymers that we're familiar with? Well, you are covered with polymers. Your hair, your tendons, your nails are all composed of polymers. Your muscles are polymers. Proteins are polymers. What are proteins polymers of? We said this the other day. Amino acids. Now, think about that. The amine and the carboxylic acid join with an amide bond, and you put a lot of those together and you get this amino acid chain, which is called a peptide if it's 40 or less than 40 amino acids, or it's called a protein if it's more than 40 amino acids. So that's a polymer. Proteins are polymers. Some other really cool natural polymers are starch, cellulose, and glycogen. Starch. We've already talked about some starchy things tonight. Corn, wheat, potatoes, rice. All of those are full of starch. Starch is a polymer of glucose. It's glucose bonded together. What do we feed countries that are hungry? Starch. Because it's what? Polymers of glucose. What is glucose in your body? Energy, right? So that's why that's used. If you need something energy-wise fast, grab a baked potato or rice or some corn or wheat, piece of bread. Because as soon as you start chewing it, it breaks it down in your mouth. And it's a very good for your brain energy, the glucose for your brain. Cellulose, we come back to that one. Let's talk about glycogen real quick. So starch is a storage polymer for glucose in plants. Glycogen is the storage polymer for glucose in your body. Where is glycogen in your body? Where is it stored? Say it. Somebody knows this. In the muscles. Glycogen is stored in the muscles and in the liver. Surely you all have been taught that in anatomy. Human nutrition? Okay. I knew most of the students usually know that about glycogen. They're the ones telling me stuff. So glycogen is stored in the liver and stored in your muscles. And it is the storage polymer for glucose in your body. Cellulose is the structural polymer for glucose in plants. Earlier today, when we talked about plants being a source for oils, and we're all like, well, that's just crazy. We don't think of that. We think of plants as being healthy, right? And they are, but so are oils in moderation. Now what you're talking about is cellulose. Lettuce, celery, green beans. What are they full of? Nothing. Is that what you're thinking? You want to lose weight? Eat those things and work harder. Seems like a rocket science thing. No, you just eat less, work more. Why do you eat salads or green beans or celery if you're trying to lose weight? What does it do for us? What does it not do for us? What's it do for you, first of all? None of you have ever? It will clean you out because it's a bulking agent. It's fiber. We call it fiber. It's cellulose. Does it fill us up? And then you're hungry 15 minutes later, right? But does it fill your stomach up? But what does our stomach and our large intestine and our small intestine not have the ability to do? It doesn't have the ability to digest it. So I'm telling you, it's a polymer of glucose, but do we break it down? No. That's why it works to use it to lose weight. We eat it and it just fills our stomach up for a while, helps clean us out, but we don't gain weight from it because our bodies can't process it. Goats, cows, horses are a little different, but goats, cows, sheep, deer, they all eat grass and leaves and honeysuckle and briars and get fat on it. Why? Because they can digest it. They have a rumen.
And what if like I add like bacon and ham to my green beans? Does that change?
That doesn't change the green beans, but you're still getting the fat and the protein from the bacon and the ham.
Okay, because I add that to my. I was just.
Yes.
I didn't think it. I thought it changed it.
It doesn't change the green beans. The green beans are still the green beans. The green beans are still the green beans. They're not changed. They're not changed. All right, synthetic polymers, polyethylene bottles, 2-liter bottles, your water bottles, all of those synthetic polymers. What was the starting material for most of those synthetic polymers? Petroleum. Petroleum. Petroleum is the starting material for most of those. All your milk jugs, all of those. All right, so let's look at this process. You've seen this more than once, but I want to look at it one more time. What's going on here in the process of polymerization? These are ethylene monomers, also called ethene monomers properly. Why is it ethene? 2 carbons and they're how bonded? Double bond, that's the ene. How many electrons are shown here? 4. 4 electrons, 2 bonds. Yes or no? If this breaks, these now are single bonded, but what do we have? An extra electron here, an extra electron there. If the same thing happens here, and this becomes a single bond, and we've got electron and electron, what are we starting to do across the table here? What do we keep doing? Making paper chains? Are we bonding them together? Do you see what's happening? Well, the electrons are making the bonds. Because what's happening is you had a double bond here. If this double bond is broken, then that's freeing up 2 electrons. And then if that same thing happens again, then can these 2 join and make a bond? And these 2 can join and make a bond, and does that just keep happening? And so if this is the monomer, you keep doing this however many times you've got enough monomers to do it, and what do you make? Come on. Monomers make polymers, okay? Y'all are like little children. Monomers make polymers. Okay? Does that make sense? Vinyl chloride makes polyvinyl chloride. Propene makes polypropylene. Tetrafluoroethylene makes polytetrafluoroethylene, which you called what? Look at the bottom. What's polytetrafluoroethylene? Look down at the bottom. Teflon. Glide dental floss is coated in Teflon. It's not different in that, let me rephrase that. It's the same in that a double bond is broken and you have electrons freed. It's different in that we're not adding extra things other than these monomers. That's the difference. But that's what I was saying when I've said you already have seen this tonight. Hydrogenation is the same breaking of the bond and adding. Except in hydrogenation, you're adding hydrogen after you break the bond. Here we are adding more monomers. That's the difference. That's the difference. But I'm glad you saw that. That's what I'm wanting you to see. I'm wanting you to see that. What would we call this? We would not call it vinyl chloride. That'd be the farthest thing from your mind. What would we call it? What's the parent? Two C's. Ethene. And then it's got chloroethene. We would call this chloroethene. Chloroethene. Why is this called propene? There's 3 carbons and 1 double bond. Do we have to put a number? No, because any way you look at it, it's going to be 1 propene, right? It can't be 2 propene. There is no such thing as 2 propene, because if it were here, it'd be 1 propene. If it's here, it's 1 propene. It's propene. This one would not be tetrafluoroethylene, but tetrafluoroethene. Where have you heard of PVC before? PVC pipes. You have heard of PVC pipe. Now, this is what I want you to see just on these polymers. This is telling us that PVC makes the blood bags and the tubing. That is very different than the PVC pipe. So what makes the PVC pipe different from these, if it's still PVC? What do you think? Say that again? Well, it's the difference in how much you use to make the product, yes. But also, would it be the number of monomers? Yeah, think about that. Just because it's called a polymer, I'm not saying it's a polymer of 50 monomers. It's a polymer of 20 monomers. It's a polymer of 5,050 monomers. You see what I'm saying? So would the number of monomers make a difference? Also, could they add other things to it? Yes, and they do. They do. All right, the next page. I want to get through the naming of the alcohols tonight. Here is what I want you to do before Monday. I want you we're going to come down here and do the alcohols right now. But before Monday, I want you to note all the functional groups of these common aromatic drugs and sunscreens. I want you to find all the functional groups. Monday, I want you to, before Monday, on Monday I'm going to quickly label these for you, but you need to label them before Monday so that you can be as fast as I am on Monday. Let's talk about alcohols. In general, this is what I'm hoping you're doing every day. Going through all the functional groups names, meth, eth, prop, bute, pent, hex, you're going over those in your brain, and you're saying anything you know about alkanes, alkenes, alkynes, alkyl halides, aromatics. You're just going through those functional groups and thinking about them. Solubility and boiling point are 2 things that continually you're going to be asked to be able to rank. So with alcohols, tell me, in general, alcohols will have what compared to hydrocarbons? Higher what? Higher boiling point, and what about their solubility? Greater solubility, absolutely. Higher boiling point and greater solubility than similar sized hydrocarbons due to hydrogen bonding. That OH. So they have a higher boiling point, I should have put hydro boiling point and greater solubility than similar sized hydrocarbons due to hydrogen bonding. The naming is very, very similar to everything else we've named, so it's not going to be foreign to you. That's why I'm going to go ahead and finish it. First thing you do is find the longest carbon chain that contains OH. Find the longest carbon chain that contains OH. Number the carbon chain to give OH the lowest number. Follow all other nomenclature rules for numbering and prefixes. And then end in OL. So let's look at the examples on the right, because these actually are some special examples. The first one we've dealt with already. What does it have carbon-wise? 3 carbons. Where is the alcohol? 2nd carbon, so the name is 2-propanol. Does that one make sense? That is mainly what you are going to deal with. We call it isopropyl alcohol or rubbing alcohol, but it properly is 2-propanol. Antifreeze. This is antifreeze. This is what you're putting in your car. 50-50 dilution of antifreeze. Keeps your radiator from bursting and cools your car down. Keeps your water from freezing in the wintertime, but cools your engine all the time. It is a special alcohol. Why? It has 2 alcohols. So when it has 2 alcohols, it is a diol. It ends in diol. So how many carbons do we have? 2. That's the eth, and they're bonded together with single bond, so that's ethane. Where are the 2 alcohols? One is on the first one is on the second one. That's why it's 1, 2, and then you use the suffix diol. Now, somebody's going to say, well, wouldn't it always just be 1, 2? No. Could you put 2 alcohols on this? Yes, you could. Then it would be 1, 1 ethane diol. So that's why it's 1, 2 ethane diol. So this is the proper name. And then the last one, we call it glycerol or glycerin. And it is a 3 carbon, that's the propane, but it has what? 3 alcohols, and that equals a triol. And that's where the ending comes from, propane triol. And then the last thing I want you to add down here is the name of one special alcohol that we will see a few times. This is called phenol. And I'm going to put those lines above it to remind you it's long E, long O, phenol. This is a special alcohol called phenol. Chloroseptic throat spray has phenol in it, if you've ever used that. Okay? All right, guys, have a really good Thanksgiving, and I will see you on Monday.